All right. Let's start with Cisco Viptela SD-WAN. That's the course we are over here. So before I start explaining Cisco Viptela SD-WAN, like you guys, we have basically like 4 words. In these 4 words, you guys are already, everybody's familiar with Cisco, and normally everybody will be familiar with this word, WAN, right? Everybody knows what is WAN. We have LAN and WAN. So whether it is LAN or whether it is WAN, guys, anytime we as admin, we are administrators, network admins or network engineers, what is the first thing we look out for? We want to do some configuration. What is the first thing we look out for? The first thing we look out for is what? Ease of management or ease of configuration. Ease of configuration. We want to, we have to configure a router or we have to configure a switch. We have to do some configuration on the switch or the router. Let's say related on the router, let's say related to routing. Maybe we have to set up some routing, dynamic routing like OSPF we want to set up. So we want the configuration to be as easy as possible. So that is what we want to look for. What is the second thing we want? Any admin? Ease of administration means what? With least administrative effort. We want to get the devices configured. Like let's say, like some bank is there. This bank now wants to start operation in a new country. Like in India, we have basically like Citibank is here in India. We have JP Morgan. We have the JP Morgan Chase is over here in India, like that. But Wells Fargo, another American bank, but they don't have any operations in India. Let's say Wells Fargo, they decided that they want to start India operations. They want to open up branches in India, and in India also they want to open up, let's say, maybe in 10 locations, 10 cities first of all to start. Later on they want that okay, they would like to have their offices or their branches in maybe 100 cities, like that. So in that case, what is our requirement? Least effort. When I say ease of configuration will be what I want the things to be done with least effort. Like let's say 10 location means 10 routers. On 10 routers, you have to configure OSPF. Normally, only the the LAN side, the subnet will be the different, and on the WAN side, the IP address will be different. But let's say you want the area ID could be the same for the 10 locations. Maybe you want to manipulate some timers, so timer manipulation has to be same. Maybe you want to manipulate the the cost formula on all the 10 routers. So we have basically least administrative effort. We want all the 10 routers like would be having what certain similarities in the configuration. There will be some dissimilarities also, like IP addresses cannot be same on all the routers, but there will be some similarities in the configuration. Something common thing in the configuration. So I cannot go one by one to each and every router and do the configuration. That will not be least administrative effort, like that. So I want it what? Duplication. So this is what is that I want. The second thing will be what? Duplication. Ease of configuration with least administrative effort. And second thing is what? Duplication. That means I want to do the configuration and want to do apply this configuration to multiple devices. And this were like these were the factors which led to the development of something called as what? These two things led to the development of something called as what? SDN, software defined networking. Software defined networking. That means in software defined networking, we want to use what? Some software, some application. Nowadays we call application as what? App. Previously, if we go back maybe 15 years back in time, 20 years back in time, nobody used to say app. Everybody used to say software or applications. Once the mobile revolution started, it became very popular. Social media became popular. So many apps, so many applications. We got this word app. So it is nothing but what? Software. Can I know your background, Tom? Like what exactly you're doing related to Cisco, at least?
Can you hear me?
Yes, I can. Yes, go ahead.
I right now I'm the my main focus is ICE, but I have a MP in switching and routing.
Okay, good. So, yes, you just now let me know about one application known as what? ICE,
Yes.
right? Right.
That's my
What is it?
main that's my main day-to-day
Okay,
work.
good. So you have this ICE basically, a software, an application like that. It's not, basically it's meant for what? AAA. Hmm. Are you also familiar with something called as what? Cisco's FTD, firepower threat defense.
Yeah, I'm familiar with ASAs, but
Okay, no
we're
problem.
getting we're getting
Okay,
acclimated with that now. Yes.
okay. So you know it at the ASA firewall, the ASA family of firewalls. No problem. When we have only one single ASA firewall, let's say, when you have only one single ASA firewall, how you can configure it? You can configure it through CLI. You'll connect to the console of the ASA. Okay, assign some IP addresses to the ASA interface, define your security level, whatever, like that, and then normally see all our network devices, they're kept where? In any organization, the network devices, the ASA, the routers, the firewalls, the servers, they will be kept where? Maybe in some organization, in some company, all these network devices will be kept in a proper rack, and this rack will be in a room. We normally call it as like a server room, or it could be a data center for some organization. How's the environment in that server room or the data center? It's very cold for some people. It's not reasonably comfortable, especially for us. These Asians. So I'm used to the temperature in centigrade. You guys use Fahrenheit, so 16 degree to 18 degree temperature. when I'm talking about 16 to 18 degrees centigrade. I don't know how much it will translate into Fahrenheit. It could be maybe, I don't know, maybe 60, around 60 Fahrenheit. Like that. This is not comfortable for humans. This is not comfortable for normal humans, like that. Especially Asians, because average temperature in Asia would be somewhere around, maybe 22, 22 to 24. This could be the range in Asia. So this is basically, we might feel cold working there. So normally what people do, on the network devices, you can't sit and connect it with your laptop connected to a router or a firewall or a switch, and you are doing the configuration sitting in the data center or sitting in the server room. So normally what people do, whether it is A7, initially brand new device, you connect through console, set up that device for what? Remote management. Means maybe you will enable telnet or SSH. I'm just writing telnet and SSH, right? And once you have this telnet and SSH configured and saved on the work, what you'll do? You'll come out from the data center, go to your workplace, sit on your desk, table, and from there now you connect remotely and do the configuration. See, you want ease, ease of configuration. You want ease of configuration remotely. That is the first thing. Now, when as I said, when like that, suppose let's say in your organization, your organization has 10 locations. For every location, you have this ASA like that. So initially, you'll do the same thing, set up these boxes for remote access like that, and then through remote now you'll be connecting. For configuring this ASA, have you heard about a software? We can configure this firewall through CLI, or we can configure this firewall, Cisco ASA firewall, through a software. I don't know, you guys are familiar about this one, ASDM. So this software defined networking is nothing but what we want to use some software. And this concept is not something new. I know this ASDM when from when Cisco introduced ASA, when Cisco first time introduced ASA, somewhere around 2005, 20 years back in time, Cisco had this ASDM with that. In case of this, as I said, the new devices, the fireport devices, FTD is basically over here. We have a software called as what FMC, Management Center, Firepower Management Center. So we are using softwares, we are using software. We are used to software because software gives us what GUI. GUI is always better compared to CLI, like that. And now using this ASDM, what I can do on single window, software defined networking basically means what we get what a single window. We get single window approach. And now in this single window, in this software, you will be able to see all your devices, and then you will be able to configure them through this. So this is called as what? Single window approach. Having a single window, you'll be able to configure multiple device duplications. You'll do it only once. You do the configuration in the software. You provide the parameters, you provide the details, whatever you want. What will be the LAN interface IP address? What will be the WAN interface IP address? Software, software like can have can have what wizard also. It can help us, it can ask us information. You start the wizard will start asking you, okay, give me the LAN IP address, give me the WAN IP address. Okay, do you want to configure static routing? Do you want to configure dynamic routing? Do you want to set up remote management? Okay, you want to set up remote. What do you want? You want telnet or SSH to be configured or both? So like that, this wizard can ask us. This makes our configuration what easy. And then whatever will provide this information, it will store this information, this software. And then next thing is what we define the configuration, and then next thing is what deployment. Here we have basically the configuration, this wizard, we define the configuration, and then next thing is what we want to deploy. And this is where the whole buzz is about. You deploy, you say yes, I want to deploy on this 10 routers. Deploy this on this 10 routers or 10 ASA firewalls. And then what it will do? It will remotely connect this software, will remotely connect to these 10 devices, and then it will push the configuration to this 10 device. So these were the factors for bringing up SDN, software defined networking, ease of configuration, least administrative effort, ease of management. Then we want this configuration to be deployed on multiple devices. So that is what we have duplication. So these were the factors for bringing up this new domain known as what software defined networking. And in this software defined networking now, like first thing with Cisco, I'm talking with respect to Cisco. Cisco comes out, they apply this software defined networking where in their data center segment. In their data center segment. So Cisco traditionally was manufacturing or selling routers and switches. Of course, they have basically their presence in security also with their famous ASA firewalls. Then Cisco before ICE, they had basically, what was it? ACS, like that AAA, one of the best product in the industry for AAA. Then ACS was for a very long time. So they renamed it with something new capabilities, and they started calling it as what? Identity Services Engine, ICE, like that. Primarily, it is basically meant for what? Authentication, authorization, accounting, and large devices. Again, ICE and all this is also for meant for what? Large devices. So routers, networking products, security products, Cisco was already there. Then Cisco started also what? Separate family of product for data center, Nexus family. And in data centers, we have very large number of switches, Nexus switches to be configured. So this is where they wanted to apply what software defined networking. So they come out first time with their solution, which is called as what? ACI, application centric infrastructure. So this was their first offering, like that. Routers are meant for what? WAN. So now basically if you see, Cisco has product for WAN also. ACI. Now for WAN also, so, this ACI become a huge success. ACI became very popular in the world for data center. Right. So with seeing the success for data center segment, what Cisco said, let us have a similar product for what WAN. Let us have a similar product for what WAN. Software defined networking product for WAN, like that. And they started developing a project which was called as what IWAN. They started developing a product what IWAN. But at the same time, what happened? There were other companies also, other vendors also. They also started their journey in software defined networking. Everybody wanted to use softwares to provide these two things minimum. Of course, ease of management is also there, ease of monitoring also. We want monitoring also to be good, like that. So what happened? By the time Cisco is creating this in their intelligent WAN, this IWAN software, like that, this segment over here, we call it as what? A, a segment was created which was called as what? SD-WAN, software defined WAN. And in this software defined WAN, there were already other organizations which they have created excellent products, like we can say Viptela, like that. So everybody started their journey for this SD-WAN segment. Everyone started that. So Cisco also started their own product for SD-WAN, like that. But then what happened? When Cisco compared their product with this other vendor's product, they found their product to be not so good. And that's the reason what Cisco did. They said that instead of developing and wasting time making IWAN more better, let us approach the competitors and ask them if they are able to sell their product to us. And that is how what happened. Cisco scrapped their IWAN project and approached Viptela, and Viptela guys, they agreed. And now what happened? It become now Cisco Viptela. Cisco buys out this company, and now that is why you have here now you see Cisco Viptela SD-WAN. Now over here also, this SD-WAN basically again we have basically in SD-WAN also we have basically two segments. One segment is for what? Large enterprises. So this Viptela, Cisco Viptela SD-WAN is meant for what? Large. This is large enterprises. Whereas there, in the market there is something called as what? SOHO segment also. Small office, home office, and another one is called as what? Small, medium businesses. This is large enterprises, multinationals, corporates, or ISPs. Like that. This is large implementations. So this Viptela, Cisco Viptela SD-WAN is solution is what? For large enterprises solutions. Whatever SOHO segment or SMB. Over here, Cisco purchased another company. They took another company Cisco Meraki. So Cisco Meraki is also SD-WAN, and Cisco Viptela is also a SD-WAN product from Cisco. So two parallel products, but for two different segments. So they are not like competitor products. It doesn't make sense to buy the same thing from two companies. So this is catering for different goods. It is catering for a different market segment. Plus, it is more related to even Wi-Fi also. This is more related to Wi-Fi. As I said, when small office, home offices, so normally it is meant for what? Wi-Fi. So clear now. The name of the course Cisco Viptela SD-WAN. Cisco Viptela SD-WAN is nothing but a course related to what? Software defined networking, or in software defined networking for what? WAN, which is conveniently we call it as what? SD-WAN, software defined WAN. Means we want to use now software to configure what? WAN. And which in WAN, when we say what is the primary device in WAN? The primary device in WAN is what? Router. The primary devices for WAN are routers. We don't want to configure the routers traditionally. We want to configure the routers. We are thinking of about what? Numbers. We are not thinking about one router, two routers. We are thinking about what? Numbers. Like maybe 10 routers that you want to configure, or you want to manage. You want to configure 100 routers or 1,000 routers. Large deployments. As I said, like Wells Fargo decided to, start their operations in India. Like, or you can, or we can say, like, McDonald's, they open their outlets all across in India. Now McDonald's is like not only major cities, major metro cities, they are basically literally in India. They are even in the far countryside also, like that. Small villages. Also today we have basically McDonald's outlets. McDonald's and KFC. These two companies outlets are literally everywhere you can see in India. So India, like if there are basically 1,000 cities, then you want to have your presence in 1,000 cities, or you want to have your presence in 5,000 cities. Hmm. Any any questions on this? So far good?
No, nothing so far.
Okay, good. Thanks. Let me now clean up the screen. So in this SD-WAN now, we are talking about now WAN. So traditionally, what were the WAN? For WAN, we require what? We need to take up some WAN service from some WAN service provider. What were the most popular WAN services earlier? We had traditional WAN services, which used to call it as what? Lease circuits or lease lines, like that. We had frame relays also earlier. We used to have ISDN also, like that. Then over a period of time, then what happened? You know, today, then, oh no, sorry, not. See, I'm missing out one of the most popular WAN services. Can you guys guess what I'm supposed to write now?
MPLS?
Yes, you're right. When this MPLS came, what happened then?
Oh no.
These two services became obsolete. Once MPLS was in, You're getting what? These two services slowly became, obsolete. And then lease lines also became less popular like that. And MPLS became one of the most popular bank services in the world. But still, MPLS is still what all these lease lines are private like that. Lease line is what like private. All these van services, traditional van services, they're all what? They are basically they work across what? A private cloud. Like that. And then what started? Parallelly, MPLS, the industry started embracing MPLS at the same time, all across the world. People started embracing another revolution. And what is that revolution?
Don't know.
Internet. Year 2000 onwards, internet started becoming what? Cheaper. And today, internet has become the most popular WAN service. So, internet, we think what public? We are using internet to access websites and all. That's it. Organizations, companies, large enterprises. Now they said what? Why? What is the reason? Internet is available anywhere. The most important reason is what? Anywhere. MPLS you cannot have anywhere. Primarily we cannot have anywhere because see, as I said, they were based on what? Private. Somebody has to create a private network. Like that. So if you have a presence in a city, then you can have that service. But if some service provider's presence is not available in that city, for MPLS, you can't have that MPLS service. Then that is where we go forward lease line. Why lease lines are still surviving in the world till date? Because lease lines, even though it's like for an organization, it is like a private van, but lease line is based on another most popular network in the world. It is called as what? PSTN network. PSTN means telephone network, the traditional, the like a century old network. So this PSTN cloud is still there in the world, existing in the world like that. Even though we have the mobile revolution now, people have stopped using landlines. Slowly, or like almost like landlines are phased out now. But still there is possibility. But telephone network is still there across the world. But then internet did something different. And internet is we have basically now what? Anywhere. Like PSTN was available anywhere in any location, any part of the country, any city, major city, small city, villages, towns, wherever you want, we have internet. Like PSTN was there, same way internet is today available for everyone, everywhere, anywhere, everywhere it is possible. And that's the reason it became popular. And now companies also started using what? Internet. Now, internet comes, whenever we have this internet cloud, what is the most important thing we want? Suppose, you know, let's take example. Okay, you have a computer at home. You have a computer at home like that. Some computer is there at home. You have this computer at home, and this is You're sitting in your office, maybe. You're using basically maybe a laptop here. Hmm. How do you access your computer at home today? If you want to, like you remember something that you have to, get some files from your server, from your computer at home. You're working, you are working on some project, so you are working on this home computer, and now you come to the office. You remember, oh, you forgot to take the copy. You forgot to take the copy of that, no, of that file. Maybe you creating some document. You forgot to copy it on a USB and carry it, or you did not work on your laptop. You work because maybe to do that thing you required higher resources. So now the question is how you're going to get this thing from this server, from your home computer you want. You cannot go now. Maybe it's like, 1 hour drive or maybe 2 hours drive home, back home. So you are at work. You cannot leave your workplace. And now you need that file also. Maybe post lunch, there might be a meeting, you have to present that file. So normally today, what people do? How do you access your home computer? We use softwares, right? Software like what? TeamViewer, AnyDesk, SOS. There are so many hundreds of softwares available in the market, remote access softwares. What we do? In that case, what happens? Your home computer must be connected to your Wi-Fi network at home, your internet at home, and on this you must have that software, let's say AnyDesk. And then you have AnyDesk over here also, and your laptop is also connected to the internet, and then now you're basically accessing your data from this server, like that. Whenever you use this software, AnyDesk or maybe TeamViewer, how that data is going across this internet. Internet is the you know is a public network. It's the most insecure network. I for internet, I for insecure also. It's the most insecure network in the world. Here, all kind of people, bad people, good people are there, but more bad people are there. Less good people. So here you have insecure. So how you want this data to be sent across this internet? You cannot have your communication in what? Clear text. You'll have your communication what? Encrypted. So concern is what? Security. You want to ensure that your data is secure. So that's the reason, on the any days also, what do we do? On the any days also, we set up what? A strong password, something like that. And then if you know the number, any days number, you enter that number, and then you enter the password, and then basically you connect. So first thing is what? I want to have what? Ensure that I'm connecting to the right server because I only know the password. So authentication, I ensure. So authentication is there. When we talk about security, first thing is what? Authentication. We want to ensure that we are connecting to the right device. And then what is the next thing? Now, once I'm connected to the next this thing, I want to ensure that my data goes what? Secured. Nobody is able to see what I'm exchanging, what I'm sending or receiving. Or if somebody, intercept my communication, if somebody is intercepting my communication, they should not be able to understand my communication. That means they require what? Encryption. I want to ensure that I don't send the data in clear text form, which can be easily read by anybody if somebody is what? intercepting and doing an attack, we call it as what? MITM, man in the middle attack. Somebody is coming in the middle of the data path. So traditionally, okay, now forget about this thing. Now think of what? Routers. We are talking about WAN. So we have a router here and you have a router here. Behind the router, there will be this LAN. This is the WAN. In the there will be a server here, and over here there will be a user. So whenever users are accessing servers like multiple. There could be multiple locations. You might have some server organization while you have server, and they have different locations. So these users are basically, sending their data. How this data is going to go now? Any idea that for this also, this is called as what? WAN across internet. And you have here what? Large deployment, 1,000 locations. Before this SD-WAN comes in the market, SD-WAN is becoming popular, or as SDN is becoming popular. Cisco already had a technology. Cisco already had a technology for large deployments. Where large deployment means what? Scalability. Duplication means what? Scalability and secured. Large deployments means scalability, and the communication will be what? Secured communication. Any idea what is that technology? They had already this solution, and because of that technology, Cisco was preferred by organizations. Cisco was preferred. It was their it was their proprietary technology. It became very popular. Like almost like this technology is also like almost like 20 years old, or 20 years, or I don't know, maybe 30 years old also, because Cisco introduced this technology first time in the market. Nobody had a competing product, and because of that, Cisco become number one choice for many organizations whenever they have large deployments, and whenever organizations want to use internet, an insecure cloud to send and receive data. Very scalable solution. Already had this thing, and this was called as what? DMVPN. Everybody knows VPN, and you have a what? Dynamic multi-point VPN, a proprietary solution from Cisco, which makes this thing, you see VPN. We want to ensure that the data does not go as it is. The data goes inside what? Secure tunnels. And these tunnels will not be easy to break. Will not be, your data is going. These tunnels will not be easy to break. Why? Because what what this technology DMVPN was using to provide security. DMVPN provides scalability also, and DMVPN provides security also. For scalability, this is Cisco's proprietary solution. They have a protocol called as what in over here they have their own proprietary protocol called as what NHRP. But what about for security? I want the data to be, if somebody intercept data, it should appear to them as what garbage. They should not make out anything. They won't be able to read it. You have done encryption. You have scrambled the data, which is the technology which is used for encryption by the industry. IPsec. IPsec is the family. Anytime anybody is thinking about encryption, this family comes in mind. IPsec. IPsec stands for what? IP security. The reason DMVPN is known as what? IPsec VPN. It is also a type of IPsec VPN because it is using IPsec. DMVPN also uses what? IPsec for security. So traditionally, so this is traditional WAN. In traditional WAN, already had their big market share because of their this product DMVPN. And now when this SDN revolution is happening, when this SD-WAN is happening, this SD-WAN revolution is happening. The developers of SD-WAN also are telling the customers that hey, you can have large deployments and you can use the very popular technology, very economical WAN service. It is cheaper. You don't need to have MPLS WAN service. Of course, people are still, organizations are still using MPLS, they are still using lease lines, but at the same time are also having what? Today, internet is becoming what? Like a primary WAN, and MPLS would be like secondary WAN service, a backup, like that. Like how in the traditional WAN, lease line used to be primary, frame relay or ISN used to be secondary WAN service. Same thing now between internet and MPLS. At one time, MPLS used to be primary, internet used to be secondary. Now it has reversed. Everything we want it across internet, and that's the reason today we have clouds also. So in SD-WAN, you want to provide customers ease of configuration, ease of least administrative effort. The configuration can be pushed to multi-duplication, scalability you want. At the same time, you also want what? Security also. So security is also a major concern with SD-WAN. And when Cisco, studied that, they said, okay, let us buy the competitor. So when they studied the SD-WAN, offering from Viptela or maybe some other companies, they found Cisco Viptela SD-WAN to be good. Why? Because this Cisco Viptela SD-WAN has what? Inbuilt security. It is like, security has been built inside, nothing like that. It has inbuilt security. This is one major factor Cisco like that. Because we are going to have the communication across what? The most insecure network, insecure cloud, internet cloud. And that's the reason they wanted what? Any communication which is going to happen should happen always what? Secured. It should be what? Secured communication. You cannot afford an insecure connection across internet. Clear, guys?
Clear.
Yes.
So
Clear.
see, security is very important. Now the thing is what? Or let us see over here. Let me. So we are talking about what, as I said, in this SD-WAN means what? Software. So software we have to use. Normally software will be where? The software will be installed where? On server. The software we install where? On server. This server, now in SD-WAN terminology, we call them as what? Controller. These servers, we call them as what? Controllers. And when I say server, software can crash. Software can crash anytime. You take any software in the world, there is always possibility for software to crash. But if we see in our networking industry, routers also have software. Routers also have software, but we never hear a router has crashed, a firewall has crashed, because the routers operating system, we call it as what? iOS. This iOS is very stable. Like that. So in networking industry, we had stability, whereas in the software industry, there is no stability. No matter how good you create a software, someday it will always crash. So whenever you have the software-based solutions, you can't have a single server. You can't have a single server. You naturally will have what? Backup. So that's the reason we call them as what? Controllers. So you require now what? Not a single. It can be what? There can be what? Multiple controllers. Like, it's not only a single server, because if you have single server, you have basically what? Single point of failure. If that server crashes, your whole SD-WAN will crash. Okay. So basically, we have what? Controllers. Again, this concept is not, as I said, nothing software defined networking. People say it's a relatively new concept, maybe like last 10 years, or maybe it's just like one decade old thing now. It could be like that. So new concept, relatively no. This software concept is already there from, as I said, no. Like I know there are certain implementations in, like when I became CCI in 2004, almost like now what, 21 years back, like that. I joined one US based, US based company for their, I was providing them remote support from India, and they wanted me to, manage their. In those days, voice over IP was becoming, IP telephony was becoming very popular, like that. So Cisco also has, their product for IP telephony. They had their product called as what? CUCM, Cisco Unified Communication Manager software. This is what nothing but a software. And in this software, we had, you know, servers. We used to call them as what? Publisher and subscriber. There used to be one publisher. So whenever any company was going for a IP telephony solution using Cisco, Cisco used to tell the customer, hey customer, you have to buy at least one publisher software, one server, one controller, and you should have minimum two subscriber, or minimum maybe three subscribers, like that. So publisher can be one, subscriber can be multiple, like that. So same way here also controllers will be not single, controllers will be what? Multiple. Because if one server crashes, you still have a backup available. Like, so we want what? The solution must be what? Scalable. Like that. Because you're now bringing software in this networking domain. Networking domain software, they're already stable. iOS is already stable. We don't see routers and switches crashing very frequently, or very rarely we hear like that a router has there could be some hardware failure. Routers don't crash. Routers also crash like that. But we don't hear as commonly as we hear, oh, Windows has crashed. The software concept is also age old, not new. Only thing is that what they wanted now to deploy software in the networking industry. That's the reason they said we call it as what? Software defined. So software is providing us these advantages of scalability and all. Now, when we are talking about WAN now, okay, let me clean up now again the whole thing. When we are talking about WAN basically, as I said, means what? Routers. WAN basically means what? Routers. So we have routers like that connecting. In traditional WAN on this router, what we do? We do routing, correct? Still I have drawn like a flat network. Let's say let us have it like a more redundant network. This is like a more redundant network now. Like that. So suppose this is router one, this is router two, router three, router four, router five. There could be six also possibly. Like, so you have like this big network. Just think about big network. Whenever you have big network, what we'll be doing? We do what? Dynamic routing. Routing is needed, and which type of routing will be preferred? Dynamic routing will be preferred. Will organization will go for what? Maybe OSPF or maybe EIGRP, or maybe somebody might go for what? BGP. Like that. ISPs will go for BGP. So dynamic routing is important. Whatever routing doesn't matter. You have to OSPF. You have to have here. You need to have OSPF here also. Everywhere you have all the routers, you have to run OSPF. And once you know configure OSPF on all the routers, what every router does, every router calculates the best path for a particular destination. Let's say on router 6, there is a network M. So now if you see, for router 1 to go to M, there are multiple paths. Either it can go via R2 or it can go via R5. Two paths are available for router 1. So router 1 will do the calculation. It will identify the best path to reach this destination network M, and then it will install this routing, this no, this best in its where routing table. So every router is maintaining what? This routing table. Every router is maintaining what? This routing table. And every router is independently calculating the best path. Every router is calculating what? The best path independently. And then once it has installed the path, let's say this every router will also have a LAN. So the LAN of router 6M is actually a WAN, it's actually a destination. It's a WAN route like that. Similarly, for router 1 also, every router will have a LAN. Its LAN will be for WAN for somebody else. My LAN is for WAN for somebody else. Others LAN is WAN for me. Like that. So let's say this is net segment X. If X is sending now traffic, first of all, M must be there in the routing table. Here in the routing table, the route must be there via maybe router 1 says that okay, to reach M, the best path for me is what? Via R2. Next stop will be what? IP address of R2, like that. Same way, this guy will say M is available via, maybe this router 2 will say this M is available via, for me it is R3, because for router 2 also there are two paths. It can reach destination M via 3 also, it can reach destination via 4 also. Every router you see, it is calculating the best path according to its own algorithm, according to its own criteria. Like, if there is a failure, all the routers have to calculate the failure. Suppose this link now here, let's say now you see R3, there is a failure here. Link between router 2 and 3 will fail. What will happen? R2 has to basically, R2 will recalculate the best path. It will say now, okay, for to reach M, for me, the best path is via R4. And accordingly now, R2 will announce that M is available to again R1. And then again R1 will calculate. Anytime there is a change in the topology, each and every router is calculating the best path. They are trying to converge as quickly as possible. Some segment maybe there won't be any change, but maximum the routers are doing this calculation. And now once they have calculated the best path, they install the best path in the routing table. Now they are ready for what? Data transfer. Now they are ready to forward packets. So now traffic comes. Traffic will come from where? Ultimately some user trying to access a server here. So when this user is sending this traffic, the router will do what? Destination based routing table lookup and forward the packet according to the route measured via R2, and the data will flow like this. Right? So you see now there are two types of thing happening on every router. We have something called as what? First you need to know, you need to have the destination information, and then you need to also know how to, when the data comes, how to forward this thing. And that's the reason every router, we say traditionally, every router is made up of what? Internal architecture of router. We say that it is made up of what? Two planes. Control plane and data plane or forwarding plane. So control plane contains what? The routing table, and data plane contains what? The forwarding information base table. Like that. So routing protocols, they install the route in the routing table, and when the data comes, when the traffic comes, when traffic is coming, the router is doing what? Forwarding the traffic as per what? The fib. So this control plane and data plane is local to the router. Everybody will, each and every router has the same thing. Control plane is also there and data plane is also there. So this is how a traditional WAN device works. We need to stop now.
Yeah, it's 1 hour.
Okay, so we'll continue then tomorrow. So this is traditional. I shown you that in traditional WAN, every router is internally has what? Couple of planes, logical planes. We call them as what? Control plane and data plane. Data plane is used for forwarding of traffic. Control plane is what? You receive the route from the routing, whatever routing protocol you configure, OSPF you configure, OSPF updates will come. That processing is done by a plane, separate plane, which you call it as what? Control plane. The control through over here we have the routing protocols. Routing protocol generate a table. We call it as what? Routing table. So routing table is part of control plane. And then based on the routing table, there is something called as what? Forwarding table also, which we call it as what? Fib. So we have two planes. Traditionally, a router is having what? Traditional routers have what? Two planes, control plane and data plane. We'll continue tomorrow. Okay.
Yeah. Thanks for waking up at 4 in the morning. It'll be
No worries.
okay.
Awesome. Thank you very much. See you tomorrow.
See you tomorrow,
Alright.
Tom. Take care.
you
Bye bye.
later.
Good night for you.
You too. Get some rest. All right, bye.
Yes. Bye.